I am now. I'm recording right now. So this is going to be part 2 of section 4.4, right? Graphing sinusoids. In the first part, we didn't actually do much graphing. We really just talked about transformations and things like that and their key features, midline, amplitude, period length, things like that. Today we'll actually get some graphing done. We'll start with a couple Mickey Mouse questions and then we'll move on to a couple challenging questions. Yes? Mickey Mouse question means it's easy. Yep. So let me tell you how I do graphing. When I look at my equation, the first thing I identify if I'm doing sine or cosine is my midline. That's always the first thing I identify. And the number at the end, y equals that number, is your midline because your x-axis at y equals 0 is supposed to be the midline. This is a vertical shift. Everything's been shifted up one, including the midline. So our midline is at y equals positive 1. After I've identified my midline, take a peekaboo at amplitude. The amplitude of this sine wave is 2. So why do I check that out first? Because you can see that this grid has no scale on it, right? We get to pick what we want our x's and y's to go by. So knowing that the midline is at 1 and the maximum is 2 above that at 3, the minimum is 2 below that, -1, we can choose our y's to go by 1 if we want to. It'll all fit. See, 1 plus 2, 1 minus 2. So it'll fit if we just go by 1s. So I'm just going to go by 1s. Y equals 1. Our maximum will be at y equals 3. And our minimum will be at y equals -1. Up 2 and down 2 from the midline. Might as well throw that midline on there right now. Now I'm probably only going to graph one period of this thing. I don't really see a reason to do more than that, but be aware that they go on forever in both directions. We decided our y scale, time to decide the x scale, and that's actually where the challenge is going to come from, deciding on your x scales. For the 2 Mickey Mouse questions, you won't really see why. So checking out the inside here, we can see how at least to find the period length. The period of every sine and cosine graph is supposed to be 2 pi. So our period length is going to be 2 pi over b, which would be the 1/4 that sits in front of this x, stretching or shrinking this object. 2/4 divided by 1/4. 8 quarters going to $2. So this is 8 pi. This sine wave is going to take 8 pi to complete one period. It's pre-stretched. Horizontal stretch, factor 4. Now, if you remember when we talked about it, is this Friday? We talked about it on, we talked about it on Friday. Today is Monday, right? Yeah. It's been a long day. We talked about how the sine and cosine waves can be split into fourths because of the quadrantal angles. Something interesting is going to happen at every quarter of the period. It's either going to be a minimum, a maximum, or we're going to be on the midline every quarter. So what you need to do in order to figure out what your x scale should be is to take your period length and figure out where your important information will be. Well, at least how spaced out it'll be. Our important points will be 1/4 of our period away from each other. So there will be 2 pi. There's going to be 2 pi between each point. So wherever we start, at whatever x we start, we're going to add 2 pi. We'll be at one of the special places. We'll add 2 pi. We'll be at another special place. So on and so forth. What I think makes this what I call a Mickey Mouse question is there's no phase shift. When there's no phase shift, no shifting left and right, questions are pretty darn easy. You have a question, sir? Yeah, minimum, maximum, or midline. Those are the special things. And this is just telling you how far apart those hits will be. So yeah, no shifting left or right makes this an easy question. Because a positive sine wave should be shaped like this. should start at its midline and go up. And both the sine and cosine parent functions begin on the y-axis. So this point right here will be on the y-axis because there was no phase shift. 1/4, 2/4, 3/4, 4/4. Those are the points that we're going to find. We could just go by 1 pi if we want to. Pi, 2 pi, 3 pi, 4 pi, so on and so forth. So here's 2 pi, 4 pi, 6 pi, and then 8 pi. Now I didn't bother putting the odd pi's on there. I could. I just didn't bother because it's not going to be any one of these 5 red dots. So the parent sine function begins on its midline, and we already said that that's going to be on the y-axis because it has not been shifted left or right. So we begin here. At our first special increment, 2 pi away from the beginning, we will be at a maximum, and then we'll be back down at a midline, minimum, midline. Ta-da! That's a pretty sine wave. You'll get there, you'll get there. Years of practice. We're all good at something, right? That's it though, that's all there is to it. Graphing's not that bad. As long as there's no phase shifting, it's pretty easy, to be honest with you. Any questions about this one before we move on to a different one? No? Okay. Then we will scoot the paper. A negative cosine wave. First things first, I always track down midline. It's going to be this number at the end. Y equals -1. Now my amplitude, well, the amplitude's 0.5. That means we're going to go 0.5 up from -1 and 0.5 down from -1. So I'm going to have my y scale go by 0.5s. Here's -0.5, here's -1, and -1.5. We can throw our midline on there. I don't remember how far over I'm going to go, so that felt good. Now we need to decide on our x scale, which means we need to know our period length and phase shift. Oh, that's right, there's no phase shift. That's good news. That means that our cosine's period will begin, quote unquote, begin on the y-axis. That's good for us. Let's figure out what the period length is. 2 pi over b. This time your b value is a 3. Holy cow. That's pretty quick period length. 2 pi over 3. So we're going to see that whole wave, well, a cosine version of it, but we're going to see a whole wave in 2 pi over 3. But remember that something important is going to happen at every quarter of that. So your important points, which are minimums, maximums, and midline hits, are going to be 2 pi over 3 times 1 over 4, because fourths, the quadrantal angles. It gives us 2 over 12, or 1/6. Right? Did I do my math right? 5 over 6? Oh, they're pi over 6 apart. And since we don't have a phase shift and this graph is going to start on the y-axis, I could just go by pi over 6s for my scale. And I'm trying to get all the way up to 4 pi over 3. I am going to stretch it out a little bit though, just because I have all the space. I mean, why not, right? So I'm going to say here's 1 pi over 6. Here's 2 pi over 6, which, by the way, 2 pi over 6 is what? Pi over 3. Here's 3 pi over 6, which, by the way, is pi over 2. 4 pi over 6, which is 2 pi over 3. That's the end. And maybe I'll 2 pi over 6, 3 pi over 6, 4 pi over 6. See, we're just going by pi over 6s. And then they're reduced, of course. Last thing we need to figure out is our shape. Our shape is a negative cosine. Since cosine is supposed to start at a maximum, a negative cosine is going to start at a minimum. We will have a bell shape like this. And our important information is going to occur there, 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 and there. So beginning at a minimum, ending at a minimum. And beginning, like we said, quote unquote, on the y-axis because we have not been shifted left or right. We start at a minimum, midline, maximum, midline, minimum. There's all 5 points. Good enough. That's not too bad, is it? It's not. Yes, ma'am. Because a cosine wave is supposed to be shaped more like a cup or a bowl. So putting a negative in front of it reflects it over the x-axis, just turns it upside down, makes it a bell shape. Anything else? No? Okay, then I tell you what, we're going to bypass the 4 quote-unquote word problems for a moment. And, well, not for a moment, for the day. We'll finish it tomorrow. And we're going to go to the last 2 examples. What to do when they're not so simple. And this is not a typo. I realized this morning I wanted to change this question. So if you would please, scribble out this plus sign. I want it to be a minus sign. It's a better question if it's a minus sign, trust me on this. Well, it's because if it says plus pi over 6, that's shifted left pi over 6. And there's only 1 tick mark here. So unless my x-axis goes by pi over 6s, a little bit screwed here, which is what happened in first period. So I told them if they go to watch this video, I will change it for last period and make it a minus sign because it'll be a much better graph. You get the good stuff, yeah. First period is my guinea pigs. All right, so I'm seeing 1, 2, 3, 4, 5 transformations on this sine wave. Yeah, buddy. Just like before, the first thing you're going to want to identify is where is your midline? Plus 1 again. The reason why these midlines are staying at positive 1 and negative 1 was just so I could get you enough tick marks up and down, so I couldn't have too much vertical shift. Our amplitude this time is 3, excuse me. Maximum goes up to 4, minimum will go down to negative 2. But there are 4 tick marks here, so we can still go by 1s on our y-axis. Yeah, 1 plus 3 and 1 minus 3. So I'm going to go ahead and go by 1s. And you might notice that I'm only putting the midline, minimum, and maximum on there, because those are really the only places we care about. Awesome. Same as before, period length. We're going to need to know the period length because cutting it into fourths is going to tell us how far apart our important points will be. Two pi over b, and our b value this time is a 4. Oh, this period length is pi over 2. It's a rather short period length. Yeah, it's a quarter. This is a horizontal shrink factor 1/4. Now we need to figure out how far apart our important points are then. One quarter of the period. Yikes, a pi over 8. I wrote 6. There, now it's an 8. Our special information will be pi over 8 apart from each other. But that does not mean we want our x-axis to go by pi over 8s. Reason why is what makes the inside equal 0. Positive pi over 6. That means the sine wave has been shifted to the right, pi over 6. Our period is going to begin at x equals pi over 6. And then the next piece of information will be pi over 8 away from that. Eek. So here's what we're going to do. We're going to quote unquote start at x equals pi over 6. So what do we want our x's to go by? What I would suggest you do is find the common denominator. Common denominator between over 8 and over 6 is over 24. So instead of saying that they are pi over 8 apart from one another, we're going to say they are 3 pi over 24 apart. And instead of saying we're going to start at pi over 6, no, we're going to start at 4 pi over 24. The period length then will be 12 pi over 24. How many tick marks is this? It's only 12. Well, that's a problem because this thing begins at the fourth one over if we go by pi over 12s. No, what we'll do is we'll just cut them all in half. Bunch of quitters. Now every tick mark is a pi over 12. These are going by pi over 12s. Our first thing is going to happen at 4 pi over 12, right? So 1, 2, 3, 4, right there. So here is 4 pi over 12. And what I'm going to show you is with a green dot. I'll use my green pen here. I'm going to put a dot at where the next important information is going to occur. It's going to happen 3 pi over 24. And since every one of these is a pi over 24, I just have to go. I wrote 12, but that's supposed to be a 24. There. It's going to be 3 tick marks away from that. So 1, 2, 3. There's going to be something special happening right there. 1, 2, 3. There'll be something special happening there. 1, 2, 3. Something special happening there. And it's going to come to an end right there. So those are the only places I actually need to mark with values. So 4 pi over 24, 7 pi over 24 because we're adding 3, 10 pi over 24, 13 pi over 24, and then 16 pi over 24. And you will see that 16 minus 4 is the 12 pi over 24s that I needed. Alrighty. Midline is at positive 1. So yeah, the hardest part about graphing trig is having to find common denominators so you know how far apart to make your tick marks. That's the hardest part. This is a negative sine wave. Negative sine waves are shaped like this. They begin at their midline, but they go down from there. And there's our 5 points. Begin at our midline. We said we begin at 4 pi over 24. I didn't mean to grab green. That was supposed to be blue. Then we go down to our minimum. Right there. Back up to our midline. Then up to our maximum. And back down to our midline. Let's see how I can do drawing this. Something like that. What? Did it? That was painful? Yeah. Now, of course, these graphs don't end, right? That's just one period. There could be more of it. There could be more of it, especially because we know that we're going by pi over 12s, right? So there should be more information, 3 pi over 24s, excuse me. There should be 3 pi over 24. This way, there should be another mark of some sort, right? So this, we were going up. So 1, 2, 3, I should be back at my maximum. And then 1, 2, 3, I'll be back at my midline. There. Like I said, it goes on forever in both directions. Why not? There is no such thing as an actual beginning point. But if we think about the horizontal shift, what we're thinking about is where it is in relation to the y-axis. And since the sine wave is supposed to begin on the y-axis, this point would have been our beginning because it's been shifted to the right, pi over 6. But that's if I wanted to call it a negative sine wave. Look, I could have said it was shifted to the left and called it a positive sine wave if I wanted to. The exact same equation, the exact same graph, but different equation is positive 3 sine, 4 in front of the x, and then instead of a minus pi over 6, this would be plus 2 pi over 24, which is a pi over 12, plus 1. And that would have been the exact same graph. An infinite number of ways to write the equation for the exact same graph. So sometimes it is pretty beneficial to throw more on there just to see what's going on. We'll make it the last example for today. You know what? Since I said what that would be, let me go ahead and write it in there. I mean, you might as well have it, right? A positive sine wave would have been y equals 3 sine. The 4 is unaffected, and the plus 1 is unaffected. The only thing that changes is the phase shift, since I'm calling it a positive sign. Positive signs start at their midline and go up, and every one of these ticks is a pi over 24, so that's 2 pi over 24 to the left, which is pi over 12. There. So these two are the exact same graph. Cool, huh? I also could have written it as a cosine wave. Positive cosine would have began right here with a shift of pi over 24 to the right. Or I could have called it a negative cosine wave starting right here. Hope you see where I'm going with this. Almost like you might be asked to look at a graph and tell me which of the following equations are this graph. Just saying. Moving on. Let's get a challenging, quote unquote, challenging cosine wave. What's neat about this one? Look at the number in front of x. It's got a pi in it. It actually does neat things. That means our x-axis is going to go by normal numbers instead of fractions of pi. But we'll get there. First things first, midline. y equals -1. Amplitude 2. Period length. Can we agree that 2 pi over b is the same thing as saying is 2 pi over 1 times 1 over b? Never mind. I'll just write it with a fraction inside a fraction. 2 pi divided by pi halves. Basically, it wants to know how many halves go into 2. 4. This period length is, no, 4. The pi's cancel. What we get is 2 pi over 1 times 2 over pi. The pi's cancel out. So the period length is just 4. So the important points are going to happen 1 unit away from one another. Our period length times 1/4. Oh, yep. Now all we have to do is hope that our phase shift has a common denominator, a very simple common denominator is this, which it does because our phase shift is also an integer. So we don't even have to play a fraction game. We could just see that we begin at 3, and then we just go by ones from there. Life is good. Life is good. What's that? I'm sorry, how did I get what? It's right there. It's just the number sitting in front. Nope. No, the one in front of the x determines how long the period length is. All right, so we're going to quote unquote start at whatever makes the inside equal 0, x equals 3. And then lastly, let's decide on our shape. It is a positive cosine wave, so it will look like a cup, a tulip. Okay, y values, just gonna go by ones because our midline's at -1 and the amplitude is 2, so we're just gonna go up to +1 and down to -3. And click your heels. Like we said, we're gonna start at a 3 and then go by ones. Integer values. So 1, 2, 3, that's where we'll start. 4, 5, 6, 7. Nah. I'll go ahead and put 1 and 2 on there too. Why not? Midline is at -1. Positive cosine waves begin at a maximum. Our maximum begins at x equals 3. 1 tick mark over puts me on my midline. 1 tick mark after that puts me at my minimum. Back up to midline, finishing up, back at the maximum. And of course, if I can graph this thing going to the right, I should also be able to graph it going to the left, just going by my tick marks. Those are pretty good looking cosine waves. Just gonna toot my own horn. What's that? I try. So even though this was the equation we started with, there are a lot of different ways to actually write this question or to write this formula. Equation, that's what I'm trying to get at. I could have started right here. I could have started at -1 instead of +3. So if we made this a +1 in here, it's the same graph. Or a -7 is the same graph. I could have called it a negative cosine wave and began right there and ended right there, which would have made that -1 if I wanted to start right there. Or I could have started right there and called it a positive sine wave, 2 sine of pi over 2 x minus 2 minus 1. Or I could have started right there on the y-axis, called it a negative sine wave, and had absolutely no phase shifting because it starts right there. Infinite number of ways of writing the exact same graph. Just depends on the phase shift and whether or not it's upside down. So just because I said it, I'm going to go ahead and write another version of it, and I will use the one that has no phase shift at negative sine. Y equals -2 sine of pi over 2 x minus 1, because I feel like that's the easiest version of this equation. Because it takes away one transformation, only shows 4 instead of 5. The equation that I just wrote starts here. And like I said, I could have started right there and called it -2 cosine, and inside the parentheses would have said x minus 1. There's infinite ways, not even multiple. An infinite number of ways. And that is it, folks, unless you have a question for me. Yeah? Well, you're going to need 5 points to show one period. I mean, it depends on what the directions are asking for. If it says graph 3 periods, then you do. Or if it says sketch the graph from x equals -1 to x equals 4. And then you would go from there to there and you'd stop. It just depends on what the directions are asking for. But really, if you can put the 5 points on there, throw one period length on there, and it's a multiple choice test for graphing, then you know which one it is. But yeah, that's it.